The National Electrical Code does not specifically prohibit running electrical conduit inside a larger conduit. However, it is essential to follow certain guidelines to ensure safety and code compliance. The inner conduit, 3/4-inch non-metallic conduit, and the outer conduit, 2-inch electrical metallic conduit, should be compatible and listed for use together. The inner conduit should be fully contained within the outer conduit with no gaps or openings. The outer conduit should be readily accessible for maintenance and inspection. A sealant approved for use with the conduit material should be applied to the ends of the inner conduit to prevent water penetration. To cross the creek, the following options can be considered: firstly, overhead crossing; secondly, underground crossing; and thirdly, borehole. Regarding overhead crossing, install the conduit overhead using poles or supports to span the creek. Concerning underground crossing, bury the conduit underground in a trench beneath the creek bed. For the borehole option, drill a borehole under the creek bed and pass the conduit through it. For this specific situation, the recommended method is to bore a hole under the creek bed and pass the inner conduit, 3/4-inch non-metallic conduit, through it. This method provides both protection and accessibility while ensuring code compliance. Consult a licensed electrician for proper sizing and installation methods. Follow all local and state building codes and permit requirements. Use appropriate grounding and bonding techniques to ensure electrical safety. Provide proper signage or markers to indicate the location of the buried conduit for future reference. Considering the installation, it's crucial to ensure that all electrical work adheres to the National Electrical Code, as well as any local or state regulations. These codes are in place to protect people and property from electrical hazards. When running conduit underground, the depth of burial is a critical factor. The NEC provides specific guidelines in Table 300.5 for minimum burial depths based on voltage levels and the type of wiring method used. For example, direct buried cables typically require a greater burial depth than conduit encased conductors. The type of soil also plays a role. Rocky soil can damage the conduit or cables, so additional protection, such as a sand bed, may be necessary. It's also important to consider the potential for erosion or shifting soil, which could expose the conduit over time. When selecting conduit, consider the environmental conditions to which it will be exposed. The electrical metallic tubing, or IMT, is suitable for indoor use or protected outdoor locations, while rigid metal conduit, or RMC, and rigid polyvinyl chloride conduit, or PVC, are better choices for direct burial or exposure to corrosive environments. PVC conduit is lightweight and resistant to many chemicals, making it a popular choice for underground applications. However, it is essential to use fittings and supports that are specifically designed for PVC conduit, as standard metal fittings may not provide a secure connection. When making bends in the conduit, use a conduit bender to avoid kinking or damaging the conduit. Sharp bends can reduce the internal diameter of the conduit, making it difficult to pull wires through. The NEC specifies minimum bending radii for different sizes and types of conduit. When pulling wires through the conduit, use a pulling lubricant to reduce friction and prevent damage to the insulation. The number of conductors allowed in a conduit is determined by the conduit size and the conductor's cross-sectional area. The NEC provides tables in Chapter 9 that specify the maximum fill percentage for different conduit types. Overfilling a conduit can lead to overheating and insulation damage. Grounding and bonding are critical for electrical safety. The NEC requires that all metal conduit systems be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards and ensures that overcurrent protection devices, such as circuit breakers, will trip in the event of a fault. Use grounding bushings and bonding jumpers to create a continuous ground path throughout the conduit system. When running conduit near other utilities, such as gas or water lines, maintain a safe distance to prevent damage or interference. Consult with the utility companies to determine the appropriate clearance requirements. Before backfilling a trench, inspect the conduit system to ensure that all connections are tight and that the conduit is properly supported. Use caution when backfilling to avoid damaging the conduit with heavy equipment. Mark the location of the buried conduit with warning tape or other suitable markers to prevent accidental damage during future excavation. If the conduit run is long, consider installing pull boxes at intermediate locations to make it easier to pull wires. Pull boxes should be accessible for maintenance and inspection. When connecting conduit to electrical enclosures, use appropriate fittings, such as connectors and couplings, to ensure a secure and watertight connection. The type of fitting will depend on the type of conduit and the enclosure being used. When working with electricity, always follow safe work practices. De-energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. Remember to obtain all necessary permits before starting any electrical work. The permit process ensures that the work is inspected and meets all applicable codes and regulations. When dealing with a creek crossing, special considerations apply. The conduit must be protected from physical damage and the effects of water and ice. Consider using a conduit that is specifically designed for direct burial in wet locations. If the creek is subject to flooding, the conduit should be buried deep enough to prevent it from being exposed or damaged by floodwaters. An alternative to burying the conduit is to suspend it above the creek on a bridge or other structure. If this option is chosen, the conduit must be securely supported and protected from physical damage. The support should be designed to withstand the weight of the conduit and the conductors, as well as any wind or ice loads. The conduit should also be protected from sunlight, which can degrade the plastic over time. When crossing a creek, consider the impact on the environment. Avoid disturbing the stream bed or banks, and take steps to prevent erosion. Obtain any necessary permits from environmental agencies before starting work. If the creek is used for fishing or recreation, consider the impact on these activities. Minimize any disruption to the creek and its users. Always consult with a qualified engineer or electrician to ensure that the conduit crossing is designed and installed safely and in accordance with all applicable codes and regulations. When selecting conductors for the conduit, choose the appropriate size and type for the application. The size of the conductors will depend on the load they will be carrying and the length of the run. The type of insulation will depend on the environmental conditions to which they will be exposed. Use conductors that are rated for wet locations if the conduit is likely to be exposed to moisture. When splicing conductors, use approved splicing methods and materials. The splices should be protected from moisture and physical damage. Use heat shrink tubing or other approved methods to insulate the splices. Ensure that all splices are accessible for inspection and maintenance. When terminating conductors at electrical equipment, use appropriate terminals and connectors. The terminals should be sized for the conductors being used and should be tightened to the manufacturer's specifications. Use a torque wrench to ensure that the terminals are properly tightened. When installing electrical equipment near a creek, consider the potential for flooding. Install the equipment above the floodplain to prevent it from being damaged by floodwaters. Use waterproof enclosures and fittings to protect the equipment from moisture. If the equipment is likely to be submerged, use submersible equipment that is designed to operate underwater. Regularly inspect the electrical system to ensure that it is in good condition. Look for signs of damage or wear, such as cracked conduit, loose connections, or corroded terminals. Repair any problems promptly to prevent electrical hazards. Keep the area around the electrical equipment clear of vegetation and debris to prevent fires and other hazards. Trim trees and shrubs that could come into contact with the electrical lines. Remove any flammable materials from the area around the equipment. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. An electrician can provide expert advice and ensure that the work is done safely and in accordance with all applicable codes and regulations. Remember that electricity can be dangerous. Always take precautions to protect yourself and others from electrical hazards. Follow safe work practices and use appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. A critical component often overlooked is the need for proper overcurrent protection. Ensure that the circuit feeding the well is protected by a correctly sized circuit breaker or fuse in the service panel. This protects the wiring and equipment from damage due to overloads or short circuits. The overcurrent protection device should be sized according to the ampacity of the conductors and the requirements of the well pump motor. For example, if the well pump motor has a nameplate rating of 10 amps and the conductors are rated for 20 amps, the circuit breaker should typically be sized at 15 to 20 amps, but always consult the NEC and the pump manufacturer's specifications for the correct sizing. Surge protection is also crucial, especially in areas prone to lightning strikes. Install a surge protective device, or SPD, at the service panel to protect the well pump motor and other electrical equipment from voltage surges. SPD divert excess voltage to ground, preventing damage to sensitive electronic components. In addition to the general guidelines, consider specific requirements for submersible well pumps. These pumps are designed to operate underwater and require special wiring and grounding techniques. Use submersible pump cable that is specifically designed for this application. This cable is water resistant and has a grounding conductor that is connected to the pump motor housing. Follow the pump manufacturer's instructions for wiring and grounding the pump. When lowering the pump into the well, use a cable grip to support the weight of the cable. Avoid using the conductors themselves to support the pump, as this can damage the insulation. After the pump is installed, test it to ensure that it is operating properly. Check the voltage and current to make sure they are within the manufacturer's specifications. Also check the water flow to make sure the pump is delivering the expected amount of water. Regular maintenance is essential for ensuring the long-term reliability of the well pump system. Inspect the wiring and connections periodically to look for signs of corrosion or damage. Clean the pump and motor regularly to remove any debris or buildup. Replace any worn or damaged parts promptly. By following these guidelines and consulting with qualified professionals, one can safely and effectively run electrical conduit to a well across a creek, ensuring a reliable water supply for years to come. Remember to prioritize safety and code compliance throughout the entire process. A thorough understanding of electrical principles and local regulations is essential for a successful installation.